Okay, welcome back. So this is part 2 of the lesson 4 on parallel lines and proportional parts. So let's carry on where we left off, which is the next part of the theorem. And so if we back up just here very quickly, you can see this is our triangle mid-segment theorem. And down here we have got the proportional parts of parallel lines corollary. And so remember, a corollary is just a spin-off or an extension of an existing theorem. And so what we have in this particular case is the corollary that says if we have got 3 or more parallel lines, and so we had a pair of parallel lines, we've added in another parallel line, but as you can see from the theorem or from the corollary, that it can be extended beyond 3 parallel lines. But if we have 3 or more parallel lines intersecting transversals, then they cut off the transversals proportionally. And so effectively what that means is whatever the ratio of AB to BC, the ratio of EF to FG will be the same. And so very important to note that AB and EF are not equal, but the ratio of them will be the same as the ratio of the other corresponding parts. And so just an extension of the triangle proportionality theorem. And so here we have been asked to write a couple of alternatives to the given proportion, which is AB over BC equal to EF over FG. Of course, we could write AB to EF, and that would be congruent to BC to FG. We could also use the entire segment, if you will, and so AC will be, the ratio of segment AC to segment EG, so the whole of the one part to the whole of the other part would be in the same ratio as any of the corresponding pieces, and so that would equal AB to EF, for instance. And so we have other possibilities as well. Okay, so let's move on. If we take that theorem that we just did and we add in an additional factor, that is that the parallel lines cut one of the transversals into equal pieces, then according to corollary 7.2, if parallel lines cut off congruent pieces on one transversal, they will cut off congruent pieces on all transversals. Again, AB is not equal to EF. What it effectively says is if the parallel lines cut segment AC into equal pieces, they will cut segment FG, is that FG? Segment EG, I beg your pardon, into equal pieces as well. Okay, and so now we're going to do our final example, which is going to use this theorem. And so if we've got 3 parallel lines, they have cut off one of the transversals into equal pieces. In other words, the ratio of those 2 pieces is 1 to 1. That means they're going to cut off equal pieces on the other transversal, which means the ratio of 2x plus 1 to x squared minus 7 is a ratio of 1 to 1. And of course, if the ratio is 1 to 1, what that effectively means is that x squared minus 7 is equal to 2x plus 1. And now we need to solve that by factoring. And so we're going to equate to 0. So I'm going to move 2x plus 1 to the right-hand side and add and subtract the like terms. So x squared minus the 2x minus 7 minus another one is where I get minus 8. I'm then going to factor that as a trinomial. So again, some of you will use the box method. Others have learned different approaches, and so we need to find the factors of x squared. And so the factors of x squared are x and x. In this particular case, we look at the factors of 8. Factors of 8 are going to be 4 and 2, 8 and 1. In this particular case, we have no choice, so we know it's going to be x and x. We need the factors of 8 that, when adding and subtracting, will yield -2. And so that should tell us that what we're after are the factors 4 and 2. The final piece of the puzzle, we have obtained -8, and so the only way to obtain -8 is with a plus times a minus. The question is whether the plus belongs to the 4 or whether the plus belongs to the 2, and so we look to the middle term, which is a negative, and that should tell us that the largest of our factors should have a negative and the smaller factor should have the positive. And so again, we could do a quick check. X squared minus 4x plus 2x will give us -2x, minus 2 times plus 2 times minus 4, -8, and so now we know that is correct. If the product of two numbers is 0, that means one of the numbers must be 0, and that allows us to solve x is equal to 4 or x is equal to -2. The last thing we need to do always is to check if either of our solutions are extraneous, meaning if we were to substitute them back in, do they produce a result which creates any problems? So if I sub in 4, we're going to get 2 times 4 plus 1, which is going to give us a segment length of 9. If we do 4 squared minus 7, that's 16 minus 7, which is 9. We're expecting them, of course, to be equal because we just solved the equation, but more importantly, 9 is an acceptable length for a segment. If we substitute in -2, so -2 squared minus 7, and now we'll start to see what the problem is. This produces 4. 4 minus 7 produces -3, and of course that represents a length, and so we cannot have a length of -3. The same issue will happen here. 2 times -2 produces -4 plus 1, which is -3, and so this produces an extraneous solution, and our final answer, x equals 4.